Good evening. A number of companies have been drilling in New York for some time. Others are new, some don't seem to be interested at all. Some are huge multinational majors, some are large independent exploration companies, and some are small companies that specialize in one or a small area. In a few minutes I'll discuss what they might know about where the gas could be in New York, but let's start with what drives them to drill in the first place. Most companies will tell you that they aim to maximize shareholder value, which means they're trying to increase the price of their stock. That's important in part because most companies need to borrow to expand, and the higher the price of their stock, the more they can borrow. Higher share prices also translate into higher executive pay packages. The single largest factor influencing the share price in this industry is the reserves that a company has on its books. As long as a company can keep adding reserves, it can keep expanding. Reserves are oil or gas in the ground which has been found or bought that can be economically extracted at current prices. There are detailed accounting rules to cover this, but that's basically how it works. Wall Street wants to see those reserves produced in increasing amounts each year. They also want to see more reserves added each year than was produced. That basically requires drilling more wells in each successive year if you want to satisfy Wall Street and your shareholders. This chart shows the rapid decline rates in shale. At the end of the first year, a shale well might be producing 60 to 70% less than its initial production rate. Production from conventional reservoirs declines much more slowly, at roughly 3% a year. This means that the pace of drilling new wells in shale needs to be much faster than it was in conventional reservoirs in order to meet Wall Street's expectations. Companies must carefully allocate their capital to maximize their chances of adding high-value reserves. They look across all of their plays and at individual wells within each play, and they pick the best. New York has some issues that make it less attractive than other places, and you've just heard a lot about the geology. Many drillers have moved to areas that have oil or wet gas, both of which are valued higher than dry gas found in most of New York. Drillers also prefer areas where they can put together large contiguous blocks for efficient drilling and infrastructure. You saw how chopped up New York can be. Even with the DEC's very weak proposed regulations, the area that can be drilled is fragmented, which increases costs. Any tighter regulations, for example, if we went to 1,500 feet from a house, the way Dallas has, compared to the 500 feet that we have in New York regs now, it would make it even harder to put together large blocks for drilling. Companies value the data, and they've been at it for a long time. Oil and gas wells have been drilled in New York since the 19th century, and the good data goes back at least 50 years or more. That data is valuable, and detailed records are kept, and most of which are kept confidential. Companies want as much information as possible before deciding where to drill or whether to buy existing wells or even a whole company. When groups of wells or companies are sold, the buyer gets to see all of the data in advance. Deeper wells provide information on the formations above them. The Trenton and Black River formations are a favorite target for conventional wells in New York, or they have been in the past. To get there, you have to drill down through the Marcellus, through the Utica, to get to the target. As you're going through, you pick up information. Whether or not a well is successful, it provides useful data for possible future drilling. Any pressurized gas that's encountered while drilling requires extra precautions to prevent blowouts, and that will be noted by the operators. Drill bit cuttings are carried to the surface and examined. Sometimes core samples are cut out with special drill bits. Well logs like this show details of the entire formation. The Marcellus Shale is actually made up of several members, the black shale of the Union Springs member has more organic content and is more productive than the gray shale of the Oak Creek member. Drillers use logs like this to determine where to frack. While companies have their own private data files, the DEC maintains a public access searchable database on oil and gas wells. Anybody can get at it. It shows those permits that are still active, as well as those that have been canceled or terminated. More importantly, it shows the locations of all completed wells, it shows the depths of formations, and it gives annual production information. It also shows dry holes and wells that have been plugged and abandoned. The yellow circles on this slide show all the completed wells that specifically targeted the Marcellus Shale. There are 27 in total. Of these, 14 never produced, were dry holes, or were plugged and abandoned. That's more than half. None of the rest produced more than 15,000 MCF a year. An MCF is 1,000 cubic feet, and that is very little gas for these wildcat test wells. The map also shows in red and blue the locations of permit applications on file with the DEC by Chesapeake and XTO, that subsidiary of ExxonMobil that Chip mentioned. They are the two largest gas producers in the US. On this map, the yellow circles represent all of the wells that either targeted the Marcellus or passed through the Marcellus while drilling deeper. The purple circles are all the wells that pass through both the Marcellus and the Utica shales. So a number of companies already have a significant amount of information in their files. When you look at the active permits in red and blue, you see that they're clustered on the Pennsylvania border. That's in the area that Jerry just mentioned. What's significant in the details behind this map are the number of companies that have left New York or otherwise shown a lack of interest. Gastem, a Canadian company, drilled 3 test wells in Otsego County. 3 of them fracked the Utica Shale, 2 of them fracked the Marcellus. All of them were dry holes. They packed up and left. Amoco drilled 6 test wells in Otsego and Shenango counties. Amoco was purchased by BP. BP would have had that data. When it was time for BP to come into the US shale play, they went to Ohio, not New York. Cabot, one of the partners in the Constitution pipeline, drilled the Marcellus well, or test well that passed through the Marcellus along the route of the pipeline. It was a dry hole. Cabot knew at the time that they were planning a pipeline, and if they thought there had been gas along that line, they would have taken leases before they announced the pipeline. They didn't do that, at least as far as we can tell they didn't. Anschutz, a large independent driller, tried some test wells in Delaware County before the shale got heated up, and when the shale play started, they came over to Tioga County, to Tompkins County, and drilled several test wells, all of which were failures, and they pulled out. Norse, a Norwegian company, went bankrupt after unsuccessful conventional drilling in Madison and Shenango counties. But before they filed for bankruptcy, they filed some permit applications with the DEC for Marcellus wells down here, south of the area where they were operating and close to those permit applications and close to the spot that Jerry identified. You saw before that the shaded part of this chart is what the DEC put in the S-guys as where the shale would be in New York, where the good shale would be in New York. The following slides show some alternative views of the Marcellus Fairway. This one is from the U.S. Geological Survey. Notice how their view has a shale just crossing into the New York border. This is the same chart that Brian showed earlier from Range Resources that was done several years ago. Again, the shale just crossing the New York border. That's more typical, and we have not been able to find any companies that have a view as broad as the DEC. This is a more recent chart based on additional drilling experience by the same company, Range Resources. The blue indicates very little shale, very little gas. And you can see that New York is mostly blue. The blank spot to the upper right is that area that Brian and Jerry mentioned as being overcooked, overmature. Chesapeake recently put out this map of the Pennsylvania sweet spot. The blue line shows their core area stopping at the New York border. That's the border. Their newly defined core of the core is further away from the border, and they have sold off all the leases shown in red, some of which come right up to the border. The recent information that we've seen from a number of companies indicates a narrower focus on Pennsylvania sweet spots with little indication of interest outside the sweet spots either in Pennsylvania or in New York. The geology, Jerry's analysis, the constraints on where wells can be drilled, and the fact that some companies are shifting their focus away from New York lead to the conclusion that there isn't much gas worth chasing here. Only that small line along the Pennsylvania border near the permit applications might be worth drilling at some point. You saw this chart earlier about what drives the industry. In order to keep Wall Street and their shareholders happy, companies have to add reserves each year. New York just doesn't have them. Companies have better opportunities elsewhere. The economic boom projected by the Department of Environmental Conservation is a fantasy. This does not mean that New Yorkers can stop being concerned about drilling, however. Not at all. Fracking and the industrialization that goes with it has impacts miles, sometimes hundreds of miles beyond the well pad. By now, most people have seen photos of well pads with drill rigs or fracking equipment. Let's look at what else is going on. Huge quantities of sand for fracking are delivered by rail from the Midwest and then by truck to the well pad. The silica dust with the sand can cause lung cancer, particularly in workers and nearby residents. There are health studies going on to determine just how bad those impacts are. Water for fracking is drawn from lakes and rivers, often far away from the well pad. Here's a park lake in Pennsylvania before water was withdrawn for fracking. Here they are setting up the pipelines to get the water out of the lake. And this is what the lake looked like after they took it. Tanker trucks like this remove brine or condensate from tanks at the well pads for as long as the well is active, not only when it is fracked. So there are trucks coming to the well periodically to take out liquids that come up with the gas. Any condensate that comes up is delivered to natural gas liquid processing plants where it can be used for, after which it can be used for chemical or gasoline blending. The brine is more troublesome. It contains both injected fracking chemicals and naturally occurring heavy metals and radioactive material, and it needs to be disposed of. Brine from Pennsylvania is already being spread on roads in New York, either for dust control or ice removal. This can occur far from the well pads, basically anywhere that the local highway departments will accept it. Once the brine is on the roads, it's only a short distance to the groundwater. Waste from fracking has to go somewhere. These injection wells in Ohio take waste delivered by truck from both Ohio and Pennsylvania. There's a shortage of disposal wells, and New York presently has no wells to handle fracking waste. However, we have thousands of played out oil and gas wells, and there's talk of converting some of them. Heavy truck traffic, potential earthquakes, groundwater contamination are all associated with disposal wells. A map of New York could look like this if disposal wells are permitted here. New pipelines like this one through a farm and around a house are already being built to move gas from Pennsylvania. Compression stations like this next to farms and across the road from a housing subdivision are needed to push the gas through the pipelines. What you can't see in this photo are the lights all night long, and you can't hear the noise around the clock. Methane emissions occur at many points in the distribution system. Some are from very old facilities and some from new facilities where the connections are not as tight as they should be. You can't see the problem with the naked eye, but you can with infrared photography. Natural gas is almost all methane. When it is burned completely, methane produces less carbon dioxide than oil or coal. However, when a portion of the methane is allowed to escape unburned into the atmosphere, it is a much more potent greenhouse gas than carbon dioxide. Few people realize that methane, when it gets in the air, is 100 times worse than CO2 for 20 years. When large amounts of methane are allowed to escape, using natural gas becomes worse for the atmosphere than burning oil or coal. When gas gets to cities along the pipeline routes, methane gas escapes from the aging distribution pipes under the streets. This photo shows a partial survey of methane emissions in Manhattan. Studies indicate about 3% of New York City's natural gas is leaking into the atmosphere. Boston surveys show similar results. Leakages in cities, emissions along major pipelines, and emissions in the gas fields call into question the whole concept of using natural gas as a bridge fuel while we develop alternative energy sources. We've heard a lot of talk recently about the U.S. exporting liquefied natural gas, LNG. This is gas that has been turned into a liquid by cooling it to very low temperatures. Here is one of several liquefaction plants in Qatar, the world's largest exporter. I've seen some of these plants myself in person, and they are massive. They are much larger than the import terminals that you might have seen, and they cost on the order of $10 billion each. There are no export terminals in North America at present, but a number of companies have plans and applications to build them in the US and Canada. These LNG plants are another source of methane emissions. Here's another plant in Nigeria. These plants have to be on the coast, using up a lot of coastal real estate in order to load specialized LNG tankers. New York is already facing a number of infrastructure issues from gas development in Pennsylvania. We don't have time to look at all of them now, so I'll stop with the slides at this point. One thing is certain, the problems will be exacerbated if drilling takes place here. Many of the environmental and socioeconomic impacts occur far from the well pad. We have had a good look at Pennsylvania over the last 5 years, so we should know what to expect. What does that all mean? If drilling is allowed to proceed in New York, a drilling boom as described by the DEC extending throughout central New York just isn't in the cards. It was overhyped from the start. It's possible at some point that there could be drilling in the small area close to the Pennsylvania border. Also, operators who don't have access to other plays may try inexpensive test wells farther from the border. New York just doesn't have the reserves to attract large-scale drilling. Some communities have already banned fracking, others are working on it. What we really need is a statewide ban. Without a ban, this is what we could have in many places across the state. Fracking in New York is a high-risk, low-reward proposition, and we just shouldn't take it. Thank you, and I will turn it over to Tony to do questions and answers.